Hello students, welcome to Spectra Education Academy. In this video, I am going to explain other set of questions which are given in previous NEET exams from the chapter Moving Charges and Magnetism. In question number 10, I explained in the previous video. Now let us continue with question number 11. In the product, F is equal to Q of V cross B. So there is a cross product between velocity of the charged particle and magnetic field is equal to QV cross. So B is like B I cap, B J cap, and B naught K cap. So for Q is equal to 1 and velocity vector is given 2I cap plus 4J cap and 6K cap. And F is equal to 4I cap minus 20J cap plus 12K cap. What will be the complete expression for B? So this is given in 21. Okay. So force on the charged particle F is equal to Q of V cross B Q of V cross B. Next up. So there is a cross product between velocity and magnetic field. Let us compare forces given. It is 4I cap minus 20J cap plus 12K cap. Yeah. So Q value is given 1 and there is a cross product. There is a cross product of V cross B. So the cross product of V cross B is this. Is equal to, so you'll have to get V cross B value, result of V cross B like this, I, J, and K. So V is given as 2I cap, 4J cap, 6K cap. And B is B, B, and B naught. Yeah, so the result of this is I of, forget about this column and this row, it is 4B naught minus 4B naught minus 6B minus J cap, column and row, so this is 2B naught minus 6B plus K cap. So therefore, it is 2B minus 4B. Yeah, so let us compare both sides. Let me rewrite. So this is I cap 4B naught minus 6B minus J cap 2B naught minus 6B plus this is minus 2B K cap. Minus 2B K cap. So let us compare. 4 is equal to I and I. So 4B naught minus 6B. Yeah, here is minus, here is minus. Straight away you can write 2B naught minus 6B is equal to 20 and last 2B, that to negative, is equal to 12. So therefore B is equal to minus 6. Making use of B, this call, you call this first equation, this is second equation, this is third. So therefore substituting B equal to minus 6 in any one of the equation. So let me substitute in the first equation. 4 is equal to 4B naught minus 6 and B is minus 6. This will be plus, taking left side, it is going to be 4B naught is equal to minus 32 after you simplify. So therefore B naught is equal to minus 8. B naught equal to minus 8. So now B has to be written as B I cap Already you got the value of B, that is minus 6 plus B j cap and B naught k cap. So what is the value of B? B value is minus 6i. Again there is B, so it is minus 6j. B naught is minus 8, so minus 8k. So second option is correct. Moving to the next question. Yeah. Statement 1. Biot-Savart law gives us the expression for the magnetic field strength of an infinitesimal current element. So that is I into dl of a current carrying conductor only. Second statement. Biot-Savart law is analogous to Coulomb's inverse square law of a charge, with the former being related to the field produced by a scalar source, ideal, while the later being produced by vector source, Q. In light of these statements, choose the most appropriate answer for the options given below. So therefore, get back the Biot-Savart law. It is B is equal to mu naught ideal. So this is the current element ideal with sin theta. This is divided by 4 pi. And this part is divided by r square. So this is Biot-Savart law. Whereas Coulomb's law is 1 by 4 pi epsilon naught. Coulomb's law in electricity, that too. 1 by 4 pi epsilon naught. Q1, Q2, two charges separated by distance r. So this is square of the distance. So therefore, statement 1 is correct and statement 2 is wrong. Moving to the next question. A long solenoid of radius 1 mm having 100 turns per millimeter. If 1 ampere of current flows in the solenoid, the magnetic field strength at the center of the solenoid is. So get back the formula, that is mu naught Ni. So N, small n is nothing but number of turns per unit length. So that is per millimeter given. So we need to convert millimeter into centimeter or meter. This is number of turns by L. So therefore, mu naught number of turns per length into I. So mu naught is equal to 4 pi into 10 to the power of minus 7. Number of turns are 100. But per millimeter. So 1 millimeter equal to 10 to the power of minus 3 meters. Current is 1 ampere. So therefore, these are the 10 square. 10 square means this will become minus 5. There is minus 3. At the denominator, this is going to be minus 2. Then next, after this is going to be 4 pi means multiplying 3.14 into 4. So it is 12.56 into 10 to the power of minus 2. So we'll have to check the answer. Yeah, 12.56 into 10 to the power of minus 2. So last option is correct. Moving to the next question. From Ampere circuit law, for a long straight wire of cross section carrying a steady current, the variation of magnetic field in the inside and outside region of the wire is. Okay, let us see. So first inside region, get back the Ampere circuit law. It is going to be mu naught I 2 pi r. Suppose if you consider inside, I by inside, current I inside is going to be pi r square is equal to, when you compare with the main current outside, this is going to be pi capital R square. So therefore, this pi and pi get cancelled. From this I, so elemental current is compared with the main current. I is equal to I R square divided by capital R square. So let us substitute. This is equation 2. This is equation 1. Substituting 2 in 1. So you'll get B is equal to mu naught by 2 pi R. In place of small I, substitute this I with small r square divided by r square. So therefore, 1 r get cancelled. So here P directly proportional to R. So therefore B increases. B increases and B is a function of R up to the boundary. Yeah. Thereafter what happens? So minimum you can consider if R equal to capital R. So this is the radius of the straight wire. So therefore, in this equation, if you substitute, B is equal to mu naught capital I. In place of small r, substitute capital R divided by 2 pi R square. So therefore, 1 R get cancelled. So now B is inversely proportional to R. So once it crosses outside boundary, it decreases, inversely proportional. So first option is correct. Moving to the next question. A closely packed coil having 1000 turns has an average radius of 6.28 centimeters. If current carried by the wire of the coil is 1 ampere, so we need to find out the magnetic field produced at the center of the coil will be. So therefore, if it is a circular coil, so therefore B is equal to mu naught I by mu naught I into number of turns by 2R. So therefore, mu naught is 4 pi into 10 to the power of minus 7. Current is given 1 ampere and the number of turns are 1000 divided by, so this is the radius of the coil R. How much is R? R is 6.28 centimeters. So 6.28 centimeters converting into meters. So there will be 10 to the power of minus 2. So this and this get cancelled, minus 5 will be left with. This is 12.56, multiplying 2 with 6.28, 12.56. 4 pi is again 12.56. So therefore, 1000 into 10 to the power of 5. 1, 2, 3. So there will be minus 2. So 10 to the power of minus 2 Tesla is 10 to the power of minus 2 Tesla. Okay, so second option is correct. Next. Two very long straight parallel conductors A and B carrying current 5 ampere and 10 ampere respectively and are at a distance of 10 centimeters from each other. So therefore, suppose this is a table, imagine like this. There is one conductor here, there is another conductor here, and which are carrying current. First one is carrying 5 amperes of current. Second one is carrying 10 amperes of current. The separation between these two is 10 centimeters. The separation between these two is 10 centimeters. We need to find out the force acting per unit length. So get back the formula. Force is equal to force between two parallel conductors carrying current. So mu naught I1, I2, L divided by 2 pi R. So here R is the distance, 10 centimeters. Now let us substitute straight away the formula. 4 pi into 10 to the power of minus 7. I1 is 5. I2 is 10. You take L down because question is force per unit length, F by L. Divided by 2 pi. R is 10 centimeters. So 10 into 10 to the power of minus 2. Yeah, so therefore, once again, this is going to be minus 5. This is 2 times. This is 20. So you can cancel 10 and 10. So therefore, 10. 10 into 10 to the power of minus 5 is correct. Otherwise, newtons. 1 into 10 to the power of minus 4 is also correct. And remember, so this is attractive force. Remember, whenever current flows in the same direction, these two conductors get attracted. So third option is correct. Moving to the next question, question number 17. Magnetic field on the axis of a circular loop of radius 100 centimeters carrying current root 2 amperes at a point 1 meter away. So therefore, this is X value and this is radius. So radius is 100 centimeters means 1 meter from the center of the loop is given by. So making use of Biot-Savart law, magnetic field induction at a distance X. on the axis of the circular coil carrying current I. So therefore, that is going to be mu naught I R square. In case of number of turns are given, we write N divided by 2 of R square plus X square whole to the power of 3 by 2. Otherwise, this can also be written as mu naught I R square divided by 2 with the R square plus X square cube. Now let us start substituting the values. Mu naught is 4 pi into 10 to the power of minus 7. I is root 2 amperes. Radius is 100 centimeters, means 1 meter only. Divided by 2. Then next, this is going to be R. R is again 1 centimeter only. 1 meter. 100 centimeters, 1 meter. 1 square. Then X. X is 1 meter. Again 1 square. Whole cube. So within this is whole cube. So what you can write is 4 pi into 10 to the power of minus 7 with the root 2. Then this is going to be 2 inside it is going to be 2 cube. Inside it going to be 2 cube means what? It is root 8. Yeah. 1 plus 1, 2, 2 cube. So inside root it is 8. So root 8 can also be written as 2 root 2. So 4 pi into 10 to the power of minus 7 with root 2 divided by 2 into 2 root 2. Root 2 get cancelled. 4 get cancelled. So therefore, pi into 10 to the power of minus 7. Otherwise, 3.14 into 10 to the power of minus 7. So since it is a magnetic field, it is measured in Tesla. So first option is correct. Moving to the next question. The shape of magnetic field lines due to an infinite long straight wire carrying current I. So therefore, suppose let us say this is a straight conductor. Suppose let us say if it is upwards. So assume that the thumb of your right hand is up. So in what way in general? In general, you get the field lines is, you get the field lines like this. So therefore, so this experiment is also can be conducted. Suppose if you choose this particular point, magnetic field will be in the anti-clock sense direction. If you choose this particular point, field will be inwards at this particular point. If you choose this particular point, field will be outward. Outward means what? Coming to, it is towards your body. So therefore, field and the current are perpendicular to each other. Suppose if current is downwards, thumbs down, same point. Suppose if current is downwards, imagine that if current is down, if current is downwards, so therefore if you choose this particular point, field will be outwards, it is towards you. If you choose this particular point, field will be inwards into the plane of page. So therefore it is into, here out dot, here it is into, here it is dot, but perpendicular. So field lines are in the shape of circle. Moving to the next question, question number 19. Yeah. So if the galvanometer G does not show any deflection in the circuit shown, the value of R, we need to find out R. So first let us find out what is the current before the galvanometer shows any deflection. So I is equal to, first one, net potential is going to be 10 minus 2. So therefore, it is 8. So I is equal to V by 400. So resistance is 400 here. So V is 8, 10 minus 2. Divided by 400. So this is 8 by 400 means 1 by 50. So I is 1 by 50. Now, this is the potential difference across this R. So therefore, we need to find out resistance. R is equal to V by I. So this V is going to be 2 volts. 2 by 1 by 50. So therefore, answer is 100 ohm. The second option is correct. Now moving to the question number 20. A very long conducting wire is bent in a semicircular shape from A to B, as shown in the figure. The magnetic field at point P for steady current configuration. So therefore, there are 2 straight conductors here and 1 semicircular coil, semicircular conductor. So this is magnetic field due to infinite conductor. So here like this. So while this is going to be the perpendicular distance. So to determine magnetic field at a given point due to infinite conductor, there is a formula. P is equal to mu naught I by 4 pi R perpendicular. R perpendicular means perpendicular to the straight conductor. So this is perpendicular for this conductor. So this is a perpendicular distance. So radius of the circular coil will be the semicircular coil will be the perpendicular distance. Sin alpha plus sin beta. So this is the formula to determine magnetic field induction at a given point due to straight infinite conductor carrying current I. Similarly, this is first portion, this is second portion. Suppose if you assume this is alpha, beta will be infinity in this formula for the case of 1. So therefore, first case, alpha in case if you take 90, this is alpha, in case 90, beta will be infinity. Beta is infinity. For the third case, this one, this straight conductor. This is second. Third case also same. Mu naught I by 4 pi R perpendicular. Sin alpha, sin beta. Now here you assume if beta is 90, alpha is infinity. So here you assume beta 90 and alpha infinity. Okay. So what about circle? Circular coil. That is semicircular. So using Biot's law, B is equal to mu naught I by 2R. Suppose if you want to have 4 pi here, you multiply theta by 2 pi. So theta is how much here? So for semicircular coil it's pi. So therefore this is 2 pi. Then don't cancel pi and pi. Mu naught by 4 pi R into pi. For semicircle, theta is equal to pi. Next. Right. So suppose if current is like this, current is rightwards. Suppose let us say this is a conductor. While crossing this particular point, field will be like this. While crossing this particular point, field will be towards our body, perpendicular. If this is a conductor, field will be, while crossing this particular point, again field will be like this. Because inwards. Yeah, so field is like this. Like this, like this, like this. Crossing this particular point, field will be. Next, after this, there is a circular coil, so current is in the anti-clock sense. So this will be inverse. Because for this particular conductor, this particular point is down. For this particular conductor, this particular point is up. So therefore, these fields are in the same direction. Whereas for the anti-clock sense of rotation, current will be inverse. Yeah, otherwise, suppose if this is rightwards, the way you rotate the fingers while crossing this particular point, field will be inverse. Field will be inverse. Even for this particular conductor, field will be inverse. So therefore, this is B1, B2. Suppose if current is anti-clock sense, in circular coil, field will be outward. So this is B2. So combinedly, B1 and B3 are inwards, B2 outwards. Okay, then you assume like this. Suppose this is the finger, right hand thumb rule. While crossing this particular point, field will be inwards. For this conductor, while crossing this particular point, field will be inwards. So therefore, this is going to be B1, this is going to be B3. So B1 and B3 get added, but from the combination of B1 and B3, B2 is subtracted. So therefore, B net is equal to B1 plus B3 minus B2. Yeah, B1 expression is, since here 90 sin 90 is 1 only, so you will be remained with mu naught I by 4 pi r perpendicular. Here alpha 90. So therefore again, here also you'll get the same expression mu naught I by 4 pi r perpendicular. So therefore this is mu naught I by 4 pi r B1. Similarly B3 also mu naught I by 4 pi r minus B2. So it is going to be mu naught I with the pi divided by 4 pi r. So this is 2. Yeah. So therefore, 2 mu naught I by 4 pi r perpendicular minus mu naught I pi by 4 pi r perpendicular. So you can cancel pi and pi here. So second option is correct. Next. Last question. A wire carrying current I along the positive x-axis has length is kept in a magnetic field. So this is the magnetic field. You need to find out magnitude of the magnetic force. Get back the formula. F is equal to I of, again there is a cross product between length and magnetic field. Yeah, so let us have the result. This length is along x-axis. So therefore, there is a cross product here. I, J, K. So length is along x-axis, this is L, 0, 0. Next, coming to B, whereas B is 2, then 3, minus 4. Yeah, you just continue to have I here. Then, so forget about this column and this row. I does not exist. Next. So minus 4 into 0, 3 into 0. So I does not exist. Minus J. Column and row. So minus 4L. Only minus 4L. 2 into 0 does not exist. Plus K. Here, column and row, 3L will exist. So therefore, F is equal to minus J and minus 4L. So altogether, this is 4LJ. 4LJ. Lj cap along with I plus 3 Lk cap. So this is in vector notation. If you find out the magnitude is equal to root over I of 4 4 the 16, 16L square plus 9L square is going to be 16 plus 9, 25L square. So therefore, I 25L square, 25L square means 5L. So therefore, 5IL is correct. Second option is correct. So in my next video, I'll continue with explanation of the questions which are given in previous NEET exam from the chapter Magnetism and Matter. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.